Okay, we're live. Thank you very much, Zara, and thank you to everybody for joining us this afternoon for our workshop. My name is John Carey. I'm General Manager of BuildingPoint SA, and I'm joined by my colleague Brent Godfrey, who's our Construction Technology Manager. So the topic of today's presentation is Get It Right on Site. The use of 3D laser scanning for infill construction verification. Brent's going to be taking us through that presentation shortly, but before he does, I'm just going to spend a few minutes giving you an introduction into BuildingPoint, what we stand for, what we represent, and what we can offer the AEC industry in sub-Saharan Africa. So I'll jump on a slide here, and first of all, I'll give you an introduction to the Optiron group. Some of you will have probably heard of Optiron. This is our sort of parent group that the BuildingPoint is within. Optiron has been Trimble's regional partner, supplying advanced positioning systems throughout Africa for about 30 years. And although probably best known for geospatial survey sector, Optiron has other divisions within the business as well, within the group. A SciTech sort of civils division, a Vantage division for agricultural solutions, and our new division called BuildingPoint SA, and we will represent the Trimble Buildings portfolio. So the Trimble Buildings portfolio that we'll be sort of offering sort of falls into sort of three areas: architectural solutions, structural industry solutions, and on-site solutions for general contractors. There are some sort of industry-specific tools, for example, SketchUp, which perhaps some of you may know previously as a Google solution, is now a Trimble product. Trimble SketchUp, typically for sort of architects and designers. We represent the Tekla range of packages, Tekla Structural Designer and TEDS for structural engineering building design, and Tekla Structures 3D BIM model tool for constructible models, and various layout technology, hardware and software for contractors. And there are some common tools that across the board help all of those different stakeholders, namely the augmented reality, mixed reality, and the 3D laser scanning, which Brent is going to focus on today. So let me tell you a little bit about BuildingPoint SA. As I've said, we represent the Trimble Buildings division, and that division is dedicated to transforming the whole sort of design, build, and operate phases of building projects throughout a portfolio of integrated hardware, software, and service solutions. So this enables architects, engineers, detailers, fabricators, general contractors, and construction managers, and also building owners to streamline communication and collaboration throughout the whole DBO lifecycle. It's all built around a package called Trimble Connect, a cloud-based collaboration platform. It's a bit like Dropbox on steroids and specific to our industry. And this all underpins Trimble's connected construction process. So the Trimble connected construction process is all about delivering projects with more control, more predictability, and through everything being connected in the whole of the life cycle. The Trimble connected construction process provides all stakeholders on the project with confidence by improving productivity, quality, profitability, transparency, safety, and sustainability. So I have a short video clip, which I'd just like to play, which sort of illustrates the point and our offering to you.
What does it take to navigate change, to recognize industry barriers and push through them, unifying teams and technologies across the entire construction lifecycle? What does it take to have every stakeholder on the same page, whether or not they're ever in the same place, with the right data at the right time to drive the right decisions? It takes the power to deliver, to boost productivity, improve quality, to champion sustainability, connecting the people, the processes, and the data through every phase of a project. It takes absolute confidence from Trimble Connected Construction to embrace change and drive digital transformation, to root out inefficiencies and exploit opportunities, accelerating the pace of your success, no matter what the future holds. Trimble Connected Construction. Deliver with confidence.
Okay, hopefully that's given you a brief taste of BuildingPoint, what we represent, and the kinds of solutions that we can offer and assist you with. With the time that we have today, we've got to focus on one particular area. I'm going to hand over to my colleague, Brent, who's going to tell you all about some of the exciting technology we have for the in-field construction verification. Thanks, Brent.
Thanks, John. Thanks for the introduction. Yeah, so today, within BuildingPoint in South Africa, my role is I get to play with all these latest and greatest technologies from Trimble, all the hardware. If we break it up into sort of divisions, we've got some set-out hardware from layout tools, GPS receivers, robotic total stations. On the 3D capture side, we've got a few 3D laser scanners that we represent. There's also a mixed reality side of things, which is the Trimble XR10 with HoloLens 2, Sight Vision, which is a outdoor GPS-enabled augmented reality unit. And also there's some collaboration with Boston Dynamics, and there's robotics, and there's a lot of automation, and that's sort of really looking at the real future of construction and where automation can take us in the future. So on our topic today, which is sort of construction verification, it's probably quite an obvious sort of answer in the question, but why is construction verification, so important to us? What is it? So for me, construction verification is about identifying errors on your construction site as early as possible, so as to minimize any rework. And obviously rework equals time, which is gain, equals money. So if we look at the construction industry today, our methodology over the last 50 years hasn't changed a whole amount. So what that means is when contractors are bidding on projects, we're still bidding on the same volume of concrete that needs to be placed, the same tonnage of steel that needs to be fixed, the same number of bricks that need to be laid. And a lot of the time, tenders are won and lost based on what the contractor is what he will accept as his profit and sometimes even loss margin on a project. So when rework has to happen, when we make mistakes on site, and our margins are so tight, that can really affect our bottom line. And it's really important. So I say it's a key part of what we do and what we need to get right. Now, over the last sort of decade, the virtual construction, BIM, and the office side of construction has come on a long way from the drawing board to sort of the BIM solutions we've got now. There's been a huge comparison between how that has moved and where the site has moved. We now have most people work with 3D design tools. We have things like 4D simulation, there's 5D, 6D, 7D. And we also tend to work in these common data environments. Everybody shares their models, and we're supposed to do clash detection to identify clashes and reduce design errors, and that's due to better communication through 3D. So how can we take these advancements that have been made in the office and bring it out into the field, and also see a return on investment and see efficiency gains out in the field as they're being seen in the office? So if we look at three different places where I believe this can happen, that would be in your layout, augmented mixed reality, and 3D laser scanning. These are technologies where I believe we can use the office to improve the field. When it comes to layout, We have tools such as robotic total stations, and we also have advanced layout tools, which not quite a robotic total station, but they replace the tape measure. These tools, they automatically set up off the site, your site control system. They automatically level themselves. They are linked directly to your 3D commentator environment that you use, your Trimble Connect, and linked to the latest revision of 3D model. And then you don't have to be a surveyor, or you don't have to understand how to use a robotic total station to use one of these tools. And it replaces the tape measure and replaces setting out errors in the first place in the field. We also have augmented reality, mixed reality, as I said, the XR10 with HoloLens 2 units. With this unit, I can stick it on my head, I can walk up to site, look at a QR code, and that QR code will bring up my design into 1-to-1 scale and in place on site. We're looking at accuracies of about 2 to 5 centimeters. Now, with that, it's a brilliant tool to be able to confirm whether your cast and elements are there, they're in place before you cast the concrete. It brings your whole design to life right in front of you before you've actually built it. You can identify clashes. And again, this device is a direct link to your Office 3D commentator environment. So all your latest models, all your latest revisions are all available to you on the headset. You can look at 3D laser scanning, which has traditionally been a data capture only tool. But now with the laser scanner, we can very accurately, we can take precise information and compare our design to as-built comparisons. And with the X7 scanner sitting there behind John, what's new to us now is we bring our designs out into the field, and we can have immediate results on this comparison right there and then in the field. We compare our as-built to our design and get instant results live in the field. So we finding errors before they become problems on site. Once again, it's important our scanners are linked to our common data environment. All the latest revisions, latest data is what is being used out on site. Our 3D scanner is now linked and become part of our office workflow, linked to in our common data environment. So I'm not going to go into all the very details about the X7 or the too technical. I do tend to get quite technical sometimes, but I'll keep it not technical, manageable. So if we look at the X7, what's new about the scanner? So it's a mid-range scanner. Trimble have specifically designed it to improve field productivity for the architecture, engineering, and construction industry. It's got great workflows for the AEC industry. It's controlled by Trimble fielding software, which runs on this tablet, which links to your scanner. It's a Windows 10 based tablet. And some of the technology breakthroughs on the scanner is the fact that it does in-field registration. What that means is I can do a scan, I move my scanner to the next location. Those two scans are then in the field live, matched to each other, stitched together in place. The jigsaw puzzle happens right there live in the field. Automatic calibration. Your investment in your scanner doesn't end at once you've purchased it. On construction sites, all our survey equipment has to be within check and within calibration. You can expect to pay between 70 and 100,000 Rand per annum on calibrations, and it's sort of about a month downtime in servicing, calibrating scanners. The X7 is self-calibrating. It's the only self-calibrating scanner. You don't need to worry about that. When you turn it on, it runs through an auto-calibration routine, gives you a calibration report every time you use it. It has basic set-out capabilities, automatic level detection. The survey grade compensator on board, which means we're looking at about 0.3 of a millimeter in level over 20 meters. It's got an integrated laser pointer, and I'll show you where that comes into play later. And I'd say most importantly is its ability to take your design and compare it to your point cloud and do those analytics in the field. If you are using it as a traditional laser scanner, which you can just for data capture, another nice great feature is that you can export directly to your industry standard format. So because you've done your registration and georeferencing all done on site, your point cloud is already in the correct place. I can export to an RCP, which is direct to Autodesk, a pod file, which is Bentley, E57 to Tekla, to other standard formats, LAS, TZF. There's a whole range of formats which I can then go straight from my scanner into my office software. So what I'm going to do is I'm actually just going to quickly run you through an example of how we use this, how this has been used in the field. What you're seeing now is typically what you would, it's the same software that is running on this tablet. I've just installed it on my computer, and we're going to run through how quickly and how easily you can do this type of thing in the field, and we can really see the benefits thereof. So what we're looking at here is it's a construction site. There's a concrete slab that's been cast, a couple of columns that are up, and each one of these triangles represents a location that I've set up my scanner. So I think we've done about 8 or 9 setups. Remember, each setup has only taken around 2 minutes to do, so it's taken me 15-20 minutes to scan, to collect this data, and it's now automatically stitched and registered together. What you'll also notice in here is I've also got my design model loaded up and in place, ready to compare on my software, on my scanner in the field. So I've got my 3D design and my scan data live with me. What we're going to do is because we can see there's lots of trees and there's lots of noise around there, we've got this option of having a clipping box, and or a section box, and we can just section out the area of interest, that the areas that we're interested in looking at. So we can just move it, and it's just a 3D box, and we can clip down to our area of interest. So I'm just going to use this clipping box. What I've got in my view, I've now got some 3D scan data, I've got a design model. So what we can do with this is we can run what we call an inspection of the field. We can set up the parameters of my inspection. So what we're doing is we're comparing our design to our point cloud. I've got these different color bands that I'm now going to color code the point cloud to represent. So I will say my maximum tolerance of about 75 millimeters, and an interval that equates to an interval of about 15 millimeters. So now every 15 millimeters, my point cloud will change color, so I'll easily be able to see where the deviations exist in my as-built scenario. It's as simple as now clicking on my inspection tool, and it's taking my model, only looking as far as what I set my maximum inspection range to be. So it doesn't have to run through the entire data set. It's just looking at what I'm wanting to analyze, and that makes it really fast and efficient. As you can see, the inspection is complete. What I'll do is I'm just going to change my point cloud density, and straight away I'll turn my model off also, just to help visualize, see the points clearer. And there I can see all my columns that were in there, and I can see how they compare to the design. I've got my scale bar here on the left-hand side, and it immediately stands out to me. I've got 1, 2, 3, 4 columns which are sitting between 60 and 75 millimeters out of position. I've got a lift shaft. You can see the wall, which is obviously it's skewed. It's not straight according to the design, as it goes from within tolerance into my sort of 45 to 60 millimeter range. And what I can do is, let me just turn my model back on. And I can take measurements between my design and my point cloud, and I can create images, snapshots of these, and I can send it directly from my device, which is got a SIM card inside, and I can email that image, that snapshot, directly to the people who will be interested in knowing whether their columns are in the right place or not. We understand that also sometimes we don't always have 3D information readily available to us. Perhaps you arrive on site and the contractor only has a PDF available, and he doesn't have access to the 3D model. That we can still do a similar thing. So within FieldLink, I'm going to load up, you can have a PDF, you choose the correct scale, which is the PDF, the scale of the PDF, and you can align it by selecting common points. You can align the PDF to your project's coordinate system. And now, for example, I've got my background map as a PDF. I can then just do a simple visual inspection. And again, I can measure between my PDF and my point cloud, and I can send those, and I can take snapshots of those deviations and send those directly off to whoever is interested. So you're not limited by your format of the information that your model you bring in. It can be a PDF, it can be a DWG, it can be an IFC, we can bring in Navisworks files, NWD documents, we can bring in TRB files, sketch, Tekla files. There's a whole range, a host of different 3D models and 2D drawing files that we can bring in and use in the field. There you can see that wall, which is deviating, which is skew. So that's our inspection tool. Another great one which we have is floor analyses. Now, floor analysis is, I think, I'm just going to quickly choose a floor, for example. What the software does is that you choose an area and it automatically eliminates all the point cloud data that is not part of the floor. So even if there's any rubble or any bits of debris on the floor, or if there's noise from people walking around or scaffolding, it takes that out within that area of interest, and it just leaves you with the lowest floor level, and then you can run some analysis on the floor in the field. So I'm going to choose floor 1. And what I'll do is I'll choose a resolution. I'm going to assume we're doing a TR34 inspection. We want a FM2 classification, and we're going to set the resolution to every 300 millimeters. Choose, I'll say our tolerance interval is 15 millimeters. And what we do is we then, as you can see, it's now created a point every 3. I'll turn off my point cloud. It might be easier to see. And now what we've done is, as you can see, there's a point that's been created every 300 millimeters, and we can see where the red is, where the high spots are, where the low spots are. And what you can also do is, in the field, it creates these contours. I can select them, I can select any one point of them, and when this is connected to the scanner, there's this aim button here at the bottom, and the scanner automatically turns and puts a laser pointer at that high spot that I choose, or at that low spot. And you can do this while the concrete is wet. So that means we are doing this floor inspection, and we are finding the high spots, and we're finding the low spots. So while the guys are busy power floating, or even before they start power floating, you can give them this report that they can see, creates a nice report with an image. They can actually see exactly where it is. And you can see where the high and the low spots are. And so the guys can work that concrete, and we can get that concrete to within specification before the concrete goes hard. So before it's set. So, and again, this is also a contractor's insurance policy. So this is a direct, immediate, detailed as-built of what the concrete as laid condition is. So if you're on upper decks, you can then scan later and you can pick up deviations, you can pick up settlement and those type of things, and you've got now proof of what the concrete looked like in high detail, exactly as it was finished, as you laid it. I think we just look at maybe some of the other type of applications that, this we can, other inspections that we could use it for. For example, applications could include facade alignments. So checking to see, if you've, depending on any type of facade you're sticking on the edge of the building, your facade alignment is critical, your slab edge is critical. If you've got an inside skin of bricks which sits on the slab, your outside skin may go past it, or any other type of expensive facade that you're attaching to your building, your alignment of your facade is very important. We can pick up these things early and we can identify where shelf angles or whatever need to be attached to rectify stuff. This survey took 13 scans in total. It took me half an hour, and we've got this detailed analysis of where things need to be addressed, and they can be way before guys even come to start installing and measuring with plumb lines and string lines and tape measures. Another great application is lift shaft verticality. We all know lift shafts are always on your critical path of your construction. They form the stability, the core of your building. So it's always under pressure. It's on that critical path. They need to go up first. And also, they have to be very precise. They have to be accurate. You tend to, 30 millimeters, 30, 40 millimeters tolerance within your lift shaft all the way through, or else your car's not going to fit. If you can scan this, you can identify any areas, or you can monitor it as it's going up. You can prevent there being any errors in the first place. And you can, if there are any, we can address them straight away. This was the entire scan, analysis, and results from the time of me arriving on site, including my site induction, was about 2 hours to produce the results for this. And this was, I think, I can't remember, it was 15 floors. I can't remember exactly how many stories, 15 floors this lift shaft in this example was. Another example where we wouldn't have thought of being able to using scanning is you're checking horizontal and vertical rebar cover. How many times do we pour concrete slabs and we come to put up our column boxes, and there's a 32 millimeter starter bar specifically in those areas where we've got transition slabs and we've got these big transition beams, big thick 2 meter deep concrete beams, and we're trying to align our starter bars coming out of these beams and these transfer decks, and to get them in places, it's quite difficult. You have to, if you imagine you're putting your marks down on your top mat of rebar, try to move it into place, and you'll end up moving the marks you go round and round in circles on site. It's a painful operation. Whereas this, I can scan the entire area, and as you can see in this picture, you can clearly see each individual bar, what the cover is, whether it's on the outside of the design, whether it's on the inside of the design. And it's so easy to take the scan, take these images, and you know exactly what needs to move where. You can also obviously see the cover to the horizontal rebar mat as well, and you can see where it's up and down and where you need to take out links and where you need to address the issue before the concrete arrives on site. You can be confident that when it's cast right. In the example where we looked at earlier was an example of where we had identified errors that had happened. Whereas if we had adopted the scanning earlier on in the construction process, like for example, in this case, here you can see the column boxes, which are sitting up on a deck. You can clearly see what we're doing is we're checking the column boxes for their position and plumb. And we can see they're all within the point cloud data around them. It's all green, it's all within 20 millimeters. So we're checking position and verticality before the concrete arrives. So we're preventing the rework from happening in the first place. I think that's the main focus of where this X7 and this field link software becomes a real usable, viable device for people to use on construction sites now, is that you make your return on your investment a lot faster. You are actually preventing any of this rework from happening. You are affecting your bottom line directly by reducing rework and improving your project timeline. And I think that's about it from me. We can probably open up to questions.
Yeah. Yeah, we're back on screen. Okay.
Yeah.
Thanks, Brent. Thanks very much. Yeah, real game changer there with some of that latest sort of technology, especially if it's not been available before. It's excellent. Thank you. Yeah, that's our presentation today. That's our workshop. So again, thank you very much for attending and listening. Hoping it's been useful insight and a taste as to the kind of things that BuildingPoint SA can offer. We've just focused on one particular sort of area today, but like I say, we're attending this event, so we're happy to talk to any of you on an individual basis if there's any interest in any of the portfolio. And for now, we can finish with any questions that have come through during our presentation.
Okay, so
thanks, Zara.
So we've asked, can AR/MR module be used separately for, say, Revit users? Yes, so for Revit users, so how the AR/MR unit works is actually, so it's linked again to Trimble Connect. Trimble Connect, any Revit models can obviously be exported as IFC files, and you can view them within Trimble Connect. Trimble Connect can open up many file formats. So it's IFCs, it's your Navisworks files, it's your DWGs, your SketchUp files. Majority of Tekla files. I don't think there's a 3D platform that we cannot get it into within Trimble Connect for HoloLens, so we're able to load that up. So if you are a Revit user, yes, 90% of the model, or a lot of the models that we get do come from Revit. So yes, Revit users can definitely use this technology and visualize the models on them. Rakesh, floor survey. How does rainwater affect the survey? Yes, rainwater is not great. We can't measure through water. So the scanner measures using light as its source of measurement. It sends out a beam of light. It comes back, does that 500,000 times every second. And if there are puddles, you'll see the slope of the floor up to as far as we get to the puddle, and it won't measure through the puddle. But you know, the idea is that we're actually doing the survey. We've tested it on wet concrete. So while concrete is being laid, while the guys are busy laying the concrete, we still get brilliant returns. The X7 has got what we call a high sensitivity mode on the scanner, which means traditionally scanners struggle with very reflective surfaces and surfaces that are the opposite, non-reflective surfaces. But in the high sensitivity mode, we get great returns on nearly all surfaces, but we still can't measure through water. But again, so while it's being cast, we want to, when there's no water on the slab, yes, we can get the results, or else, yeah, we would have to dry the slab if we wanted to know where if you wanted to get those very low points. But we should have that information in this workflow. We'll have that information before the slab even gets wet, so we wouldn't need to survey it during after it's rained.
Right.
One question: what's the cost of an X7? Come visit us on our booth. Drop me an email, and let's discuss it. If you buy 10, I'll give you a 10% discount.
Steady on.
Thanks, Brent and John. We have put your contact details in the chat box for anyone to get in touch with you. I just want to take a pause just to see if there are any last questions in the chat, just to see if there's anything. I do believe Zara's saying another one is coming through. Okay.
Absolutely. So the question, can the scanner be done on old concrete structures produced in asphalt? 100% it can. So although we've shown you a lot of what the analysis type, how the analysis works and how we do is a whole bunch of in-field analysis, the scanner, as scanners have been used up until this, that functionality is still there. We can still scan what we call scan to BIM. We do 3D laser scanning. What's nice about this scanner is actually even that workflow is improved by the fact that we scan the old concrete structures, we scan the existing buildings, and before you've left site, your scan is stitched together, it's colorized, and it's exported directly into your modeling software format. So from the scanner, but it's on your way home, while you're driving home, you're busy exporting an RCP file. If you're going to be doing as-built, you're doing your as-built drawing in Revit, for example, or you're exporting a E57 file if you're doing it in SketchUp, for example. There's your capability to do scan to BIM and data capture, and is exactly the same as it would be with any traditional any other scanner. It's just the difference is this one has got the added advantage that not only does it do the scan to BIM and data capturing and for as-built, it also does bring your design into site and do analysis in site to try and take advantage of some of those gains that people have made in the office side of construction.
Scan the rebar.
Titan Limp asked, as-built details like rebar details? Absolutely. So if you saw on that the presentation we did before, the rebar was, we scanned the rebar before it was cast so that we could actually compare the rebar to the design model before the concrete was cast, and we could analyze, actually see what the rebar cover was going to be before it was cast, and we could fix those areas. But that, at the end of that scan data is captured, and yes, we have as-built in every single piece of rebar has been scanned and forms part of your as-built. So if you wanted to as-built details such as rebar, absolutely. It's, that's the nice thing about doing this and using your scanner for analyzing as well for these type of things. As you land up, it becomes a more useful tool on site, which means you're scanning all the time on site, which means you're capturing a whole lot more information as far as your frequency of data capture and your as-built information. If you ever want to go back and check the records of where you were at a certain point in the construction phase, you probably find you've got that information on one of the scans that you've done previously. So because of it being a more useful tool, you land up with a whole lot more as-built detail, things like rebar and stuff like that as well, just come as a added bonus.
Okay, I've just confirmed with Zara, and I don't think there's any more questions. So a big thank you to Brent and John for joining us today. It was a very, very interesting presentation, and wow, what technology can do, right? So thank you very much for joining us today, and thank you to all of those of you who attended, and we hope to see you at our next workshop. Thanks, guys.
Thanks, Tracy.
Thank you very much,
Thank
Tracy.
you very much.
Bye.
Cheers.